Welcome back. In front of us, we have a question that reads, the figure below shows a ray of light incident on a triangular glass prism. The apex angle A is 60 degrees and the refractive index of the prism is 1.52. If the angle of incidence is 55 degrees, determine question 1, the angle of refraction R1. Question 2, the angle of incidence R2. Question 3, the angle of emergence E at the surface of AC. Question 4, the deviation D at this angle of incidence. Question 5, the minimum deviation dm of the ray of light with this prism. Question 6, the value of angle theta at the given angle of incidence. So this is the triangular glass prism. The apex angle is 60 degrees, which is also called the angle of the prism. It is the angle between the two refracting surfaces, that is AB and AC. At surface AB, the angle between the incident ray and the normal is called the angle of incidence. When a ray of light enters the triangular glass prism, it undergoes refraction. So this line is the refracted ray. As the light ray comes out of surface AB, it becomes refracted again, as you can see. So the angle between the normal and the emergent ray is called the angle of emergence E. One thing you have to understand is that if this light ray has to be reversed, it is going to follow the same path as stated by the principle of reversibility of light. We will now move on to solve the problems. Solution. Question 1. The angle of refraction. R1. If we analyze the diagram, the angle between the normal and the refracted ray is R1. This is what we want to find. The angle of incidence is given as 55 degrees. So I is equal to 55 degrees. We know that the refractive index of this prism is 1.52. So using Snell's law, we know that the refractive index is equal to the sine of the angle of incidence divided by the sine of the angle of refraction. So the angle of refraction at surface AB is R1. Okay? According to Snell's law, the sine of the angle of incidence divided by the sine of the angle of refraction is a constant. So that is how you find the refractive index. The refractive index is 1.52. This is equal to sine, the angle of incidence is 55 divided by sine R1. If I cross multiply, I will have 1.52 sine R1 is equal to sine 55. So I can divide both sides by 1.52. This will cancel this. Sine R1 is equal to sine 55 divided by 1.52. We will have 0.5389. Okay? So if I want to find R1, that will be the sine inverse of 0.5389. R1 is equal to 32.6 degrees. Moving on to question 2, we want to find the angle of incidence R2. What we have to understand is that the relationship between R1 and R2 is the sum must be equal to the angle of the prism. Moving on to answer question 2, the angle of incidence R2. We have stated that the angle of the prism is equal to R1 plus R2. The angle of the prism is 60 degrees. This is equal to R1 is calculated as 32.6 degrees plus R2. So 60 degrees minus 32.6 degrees is equal to R2. 60 minus 32.6 is 27.4. Therefore, R2 is equal to 27.4 degrees. Moving on to question 3, it wants us to find the angle of emergence E. So what I want you to understand about this point is, if the ray of light is moving from the glass to the air, the angle of incidence is R2, the angle of refraction will be E. But if you are considering the reverse, that is, the ray of light is moving from the air to the glass, the angle of incidence will be E, the angle of refraction will be R2, as stated by the principle of reversibility of light. If we want to use the given refractive index to find the angle of emergence E, we have to be very careful. The refractive index is if you are considering the sine of the angle of incidence to the sine of the angle of refraction, that is from air to the glass. It is also going to be the same for surface AC. Okay, the given refractive index is for the ratio of the sine of the angle of emergence to the sine of R2. So moving on to answer question 3, the angle of emergence. E, we know that the refractive index is equal to the sine of the angle of incidence, that will be E, divided by the sine of the angle of refraction, so that is R2 at surface AC. Okay, we are considering light moving from air to the glass, so that is the refractive index that is given as 1.52. You can also use the formula, the inverse, that is 1 all over the refractive index is equal to sine R2 divided by sine E. That is, if you are considering the movement of the ray of light from the glass to the air, then you can be able to use this. So we are going to make it simple by using the refractive index is equal to sine of the angle of emergence divided by sine R2. That is when we are considering the movement of ray of light from air to the glass. Okay, so the refractive index is 1.52. This is equal to sine E divided by sine R2 is 27.4 degrees. Sine E is equal to 1.52 sine 27.4 by cross multiplying. So sine E is equal to 1.52 sine 27.4 gives 0.6995. To find E, that will be the sine inverse of 0.6995. So the angle of emergence is 44.4 degrees. Moving on to the fourth question. It wants us to find the deviation D at the angle of incidence. So what is the deviation? That is this angle that we have here. Okay? If we stretch the incident ray and the emergent ray, they are going to form an angle. That angle is called deviation. So how do we calculate that? Question 4, the angle of deviation. D. You have to know that the deviation is equal to the angle of incidence plus the emergent angle minus the angle of the prism. So what is the angle of incidence? That is 55 plus the emergent angle is 44.4 minus the angle of the prism is 60. 55 plus 44.4 minus 60 will have 39.4 degrees as the angle of deviation. Moving on to question 5. It wants us to find the minimum deviation of the ray of light with this prism. So that is the least deviation. Question 5. The minimum deviation. dm. We're going to use the formula, the refractive index is equal to sine into the angle of the prism plus the minimum deviation divided by 2 all over the sine of the angle of the prism divided by 2. So what is the refractive index? Is 1.52. This is equal to sine into the angle of the prism is 60 degrees plus minimum deviation divided by 2 all over sine of the angle of the prism is 60 divided by 2. So we'll have 1.52 is equal to sine 60 plus dm divided by 2 all over sine 60 divided by 2 is 30. So if I cross multiply, I will have 1.52 sine 30 is equal to sine 60 plus dm all over 2. 1.52 sine 30 is 0.76. This is equal to sine 60 plus dm divided by 2. So we can rewrite this as sine 60 plus dm divided by 2 is equal to 0.76. I can send this sign to the other side as the sine inverse. So we can say 60 plus dm divided by 2 is equal to the sine inverse of 0.76. So 60 plus dm divided by 2 is equal to The sine inverse of 0.76 is 49.5 to 1 decimal place. So if I cross multiply, I will have 60 plus dm is equal to 2 times 49.5. 60 plus dm is equal to 2 times 49.5 is 99. So we can say dm is equal to 99 minus 60. dm is equal to 39.0 degrees. So that is the minimum deviation. Moving on to the final question. Question 6. It is asking us to find the angle theta. So how can we find the angle theta? Well, we know the value of R1 and R2, so we can easily find the angle theta because these three are in a triangle, and sum of angles in a triangle is 180 degrees. Question 6. The value of angle theta. We can say R1 plus R2 plus theta is equal to 180 degrees because of sum of angles in a triangle. So what is R1? R1 is 32.6 and R2 is 27.4. (32.6) plus 27.4 plus theta is equal to 180 degrees. 32.6 plus 27.4 is 60 degrees plus theta is equal to 180 degrees. So theta is equal to 180 degrees minus 60 degrees. Theta is equal to 120 degrees. And that answers the question. Please subscribe to the channel, like and share our videos.